All right, hi guys. Welcome to our math lesson for today. I'm just kind of trying to orient my camera. That will work well enough. Okay, so we are going to continue our exploration with multiplication today. And this time we're going to be talking about using order and grouping as ways to multiply. So first I want to just kind of introduce three really big terms for multiplication. We've talked a little bit about some of them already, I think one in particular, but I'm just going to go ahead and say, so we've talked about some properties of multiplication. Properties just mean things that make up something. So some things that are specific to multiplication that are unique. One is that any number multiplied by 0 is always going to be 0. Another property is any number times 1 is always going to be itself. So we've tested that by saying if I have 5 groups with nothing in them, then I still have nothing. It doesn't matter how many groups I have. If I don't have anything in them, I'm still going to have nothing, right? We can also test it out with 1 by saying if I have 5 1 time, then I have 5. Or if I have 1 5 times, I also have 5 of something because I have 1, 2, 3, 4, 5 times. I have 5 of something. So what I just did just there is I flip-flopped my numbers, right? First I wrote it as 5 times 1 equals 5. And then the second time I wrote it as 1 times 5 also equals 5. So this is where the big terms are going to come in. That property is known as the commutative property, which sounds big and fancy and important, but basically just means that in multiplication, order doesn't matter when we multiply. We can use our factors in any arrangement that we like, and we still get the same product, the same answer. So, for example, if I say now I have 5 2 times, or 2 5 times, as we've seen with our multiplication chart, we still get the same answer of 10 in both cases. So that can come in handy because maybe if you don't know your one of your facts, so let's say, for example, that we use, instead of 2, we multiply 5 times 7. We may not know our 7's facts yet. We actually do. But if we're not as familiar with our 7's, we can use what we know by flip-flopping our numbers to still solve. We can say, oh, I know that 5 times 7 is 5, 10, 15, 20, 25, 30, 35. And so I know that it's going to be the same thing even if I have the 7 in front. Now, commutative property just means that I can commute, I can change the order of both of my factors and still get the same product. I like to think of it as when you commute from home to work, this is point A, and this is point B. Here's my home, and here's my work. If I'm going from home to work, I travel this distance. If I'm going from work to home, I still travel the same distance. So my commute from home to school, from point A to B, is going to be the same as going from B to A, from work to home. It doesn't matter which direction I go, I'm still traveling the same amount of distance. Okay, so that is the commutative property. So that's one property that we're going to explore a little bit more today. But basically, commutative property is that order doesn't matter when we multiply. And I like to go ahead and introduce some hand gestures with this too. And so for commutative property, we make like a Y, and we can just turn them. So we have one number here, and then we can flip-flop them, and we still get the same answer. Okay, the next property we're going to talk about is the associative property. And associative property means that Associates are people who work together or a group of people. So the associative property basically means that you can group your numbers any way you like in multiplication and also still get the same answer. Okay, so that comes in more handy if we're multiplying more than one number. So for example, if I say I have 5 times 1 times 2, I could say I'm going to do 5 times 1 first, get 5, then multiply it by 2 to get my answer of 10. But I could also do it the other way, where I say I'm going to group 1 times 2 for 2, multiply that by 5, I still get 10. Now, that's not the clearest example because I'm using 1. So let's go ahead and change it around and say that I have 3. So first I can group them to say I have 5 times 3, that would be 15. 15 times 2 equals 30. But I can also say, I'm going to change these around, get 3 times 2 first. So then I'm saying I have 5 times 3 times 2 would be 6. 5 times 6, 5, 10, 15, 20, 25, 30. I still get the same answer. So associative property means you can group numbers any way you like in multiplication and still get the answer. The hand gesture I like to use for this one is this. This kind of reminds me of those parentheses, grouping the numbers together, and also just bringing things together as a group. So associative property. Commutative property, associative property. All right, the last big one that we're going to talk about is the distributive property. And you hear the word distribute in distributive. Distribute means that you can piece things out. If you distribute something, it means that you give it out, you break it down into different parts, right? So I might distribute the plates if I'm having people over for dinner first, and then I might distribute napkins as well. So I'm going to distribute those different parts. So to distribute just means that we're going to kind of break them up, and that's exactly what we're doing with the distributive property in multiplication. We are breaking apart numbers so that we can make the problem easier. And we've already done some work with that, right? So thinking about what we talked about in our last lesson with multiplying by 7s and 8s, if I say I have 5 times 8, I can think about my 8 as being made up of 4 plus 4. Then I'm going to distribute by saying I'm going to multiply my 5 times 1, 4, 5 times the other 4. In both cases, I'm going to get 20. So I'm going to add 20 plus 20 to get 40. Now I could also double check that by counting by 5s and saying I have 5, 10, 15, 20, 25, 30, 35, 40. That would be 5, 8 times. And so I would still get the same answer as if I break it up, if I break the 8 up into 2 4s, right? So same with 4, double doubles. Say I have 5 times 4. Also thinking of 4 as 2 plus 2. 5 doubled would be 10. 5 doubled again would be another 4, 20. So these are just big fancy ways of saying things that we have already been working on, but we're going to go ahead and see them in action a little bit. Oh, I'm sorry. Commutative property. Order doesn't matter when we multiply. We still get the same product. We still get the same answer. Associative property. We can group numbers any way we like in a multiplication problem. Same answer. And distributive property. I use this for distributive property. Distributive property means that we can break apart numbers any way we like and still also get the same answer. So multiplication is kind of like magic that way. That's how I like to think of it anyway. All right, so we're going to go ahead and move on into your packets now. because we're talking about 3 different properties today. So we've got a lot to cover. So go ahead and turn to page 183 in your packet. And you'll notice that there is a question. It says, Ava's mom buys 2 packs of 3 t-shirts. So Ava's mom has 2 packs. Each pack has 3 t-shirts in it. And then it says her dad buys 3 packs of 2 t-shirts. So her dad buys 3 packs and each pack only has 2 t-shirts in it. How many t-shirts do each of Ava's parents buy? So if I'm going to show a model, here I have Ava's mom has 2 packs of 3 t-shirts each. We see that I have 3 and 3 make 6. So I have 6 t-shirts altogether. Now Ava's dad buys 3 packs of 2 t-shirts. I have 2, 4, 6. I'm still getting 6 t-shirts. So each parent buys 6 t-shirts. We're just showing it in different groupings, right? But we got the same answer. So go ahead and turn to page 184 now. And I want us to look at problems 1 and 2. Number 1 says write 2 multiplication equations to show how many t-shirts Ava's mom and dad buy. How are the equations alike and different? So we've already done that. We said that Ava's mom bought 2 packs times 3 in each pack to get 6. We said Ava's dad bought 3 packs with 2 shirts in each pack for also 6. Now, how are they alike? Well, they're alike in that they all use the same numbers, right? I'm going to actually switch to a different color of marker here to show this better. I have a 2 here, and I have a 2 here. I have a 3 here, and I have a 3 here. I have a 6 here, and I have a 6 here. So they are all using the same digits. The only thing that's changing is the order, right? So here I have 2, then 3, and then 6. Here I have 3, and then 2, and then 6. So I've flip-flopped those factors. I've flip-flopped them, meaning that I've changed the order of them, but I'm still getting the same answer. All right, number 2, where it says look ahead, says you've seen how the order of factors in a multiplication problem affects the product, which means that it doesn't. But what about how you group factors? Look at this problem. David buys 4 boxes of hot dogs. Each box has 2 packs. Each pack has 5 hot dogs. How many hot dogs did she buy? Okay, so here we're dealing with 3 different numbers, right? So we have Jaden buys 4 packs. Of hot dog, or I'm sorry, buys 4 boxes of hot dogs. Each box has 2 packs, so each box is made up of 2 packs. And each pack has 5 hot dogs. All right, so for every box, I have 2 packs. For every pack, I have 5 hot dogs. So I could still count up by saying I have 5, 10, 15, 20, 25, 30, 35, 40. I have a total of 40 hot dogs, right? But we can also break this apart. We can say that I have 4 boxes times 2 packs for each box times 5 hot dogs for each pack. So I can think about this. I can group these by either grouping my 4 and my 2 together first to make 8, and then multiplying my 8 by my 5 to get 40. So that's one way that I can do it. I can also do it by grouping my 2 and my 5 together. So now instead of 8 times 5 to make 40, I have 4 times 10. That 2 times 5 would make 10, but I'm still getting the same answer of 40. So no matter how I change my order, I'm still getting the same answer. All right, so let's go ahead and skip a couple pages. Turn please to page 187. So for this one, we're going to be looking at, this problem says, Chad, actually we're going to be working on page 188 because the problem is still at the top of the page. Chad reads books at the library each week for 6 weeks. He reads 3 books each week, sorry. So here's Chad. He goes to the library each week for 6 weeks. And for all of those, for each week that he goes, he reads 3 books. Okay, so we would have an equation that would look something like this. For 6 weeks, 3 weeks a book, 3 books a week. So Chad would read, we would have an equation that would look like 6 times 3. Now the next part says that Mia also reads books at the library, but Mia reads for only 3 weeks, but she reads 6 books each week. So she only reads for 3 weeks, but she reads 3 books each week. Now the question is saying, who reads more books at the library, Chad or Mia? So let's go ahead and draw out a model again and then compare our answers. So we already know that we should be getting the same answer, right? Because our numbers are the same. They're just flip-flops. So we know that our answers are going to be the same. But let's just go ahead and visualize it. So Chad, he has 6 weeks. But each week has only 3 books in it. So that's 3. 3 more would make 6. 3 more would make 9. 3 more would make 12. 3 more would make 15. 3 more would make 18. So Chad read 18 books. All right. Now for Mia, she only went to the library 3 weeks. But each of those 3 weeks, she read 6 books. Now I'm going to use some of my distributive property here because notice I made my groups of 6, or my books, my 6 books, as 5 and 1. So I'm going to start by counting by 5. 5, 10, 15. And now I'm going to go back and add in the 1. So I have 15, 16, 17, 18. Sure enough, they both read the same amount of books. Now below, it says you can picture it. They've drawn out an actual picture. I use my simple math pictures, but they're showing the same thing. Chad has 6 weeks with 3 books. Mia has 3 weeks with 6 books. They have the same number. They both have 18 books by the end of their time. They also have underneath a model it where you can go ahead and use an array to help you. So if we were to draw an array for Chad, we would have 3 rows with 6 books. 1, 2, 3, 4, 5, 6 in each row, right? So this would be Chad's array. For Mia's array, we're going to have 6 rows. Oh, there we go. There we go. 4, 5, 6. Am I still on camera? Yep. But instead we have 3 in each of those 6 rows. Now, what's nice about an array is you can visualize it. That array is basically the same as this array, only I take it and I put it up, right? So they both still show 18 books, but the orientation is different. This one is flat, this one is straight up and down. Okay? We would call this one a horizontal orientation and this one a vertical orientation. All right. So we're going to go ahead and turn the page. Oh, that my pages are sticking together. There we go. We're going to go ahead and turn the page. Actually, we're going to go ahead and turn several pages because we covered the information on page 189. If you would like, this is optional, but if you would like to have some more practice with the commutative property, you can go ahead and complete the problems on page 189 and 190 on your own. But to make this lesson a little bit shorter, since we're covering a lot, we're going to go ahead and not cover those in this lesson. So again, it's optional, but you could come back and do pages 189 and 190 on your own. You don't have to, though. Turn the page again, and on pages 190 and 192, we'll be covering these in our practice page session on Tuesday, so you can keep turning. So go ahead and turn to page 194. And now we're talking about Nicole, with an interesting spelling of her name, Nykole. Are artists, maybe, and they decided to give her an artistic sounding name, or artistic spelling name. So Nicole decorates a pair of gloves with plastic jewels. See, I told you, artistic family. She glues 3 jewels onto each finger, including thumbs. How many jewels does she use? Okay, so for this problem, we have a couple of gloves, right? So we know that we have 2 gloves. We need a glove for right hand and for left hand. But you know what I mean. So we need 2 gloves, right? So we have 2 gloves. We also know that each glove has 5 fingers if you include the thumb. So 1, 2, 3, 4, 5 on this glove. 1, 2, 3, 4, 5 on this glove. Oops. 5. There we go. And Nicole, artistic Nicole, is going to glue 3 gems on each finger, on each glove. So we should have something that looks kind of like this. We should have an equation that says we have 2 gloves. Each glove has 5 fingers. And on each of those 5 fingers on the 2 gloves, we're going to put 3 jewels. Okay? So that would be just one. 2 gloves to do. Okay. Now this is a great opportunity to use that associative property. You could draw it and make a model, but you could also go ahead and decide how you want to group your numbers together. So I could say I like 2 and 5 together because I know that makes 10. And then any number times 10 is going to be like itself, 0 at the end. So I know that so that may be an easier way for me to think about it. However, you may also decide to say, oh, I'm actually going to group 5 and 3 because I know that then I can just double whatever that number is. So it would be like saying 2 times 5 times 3, 5, 10, 15. 15 and 15 makes 30. Same answer, different grouping. Okay? So that would be like the model it down at the bottom of the page. You can go ahead and model it by writing out an equation with 2 different groupings, or you could also draw a picture like I've done up here. So both valid strategies. So same thing, we're going to go ahead and skip pages 195 and 196. If you feel like you need some extra practice on these concepts, I would highly encourage you to look over those pages and answer the questions. But I'm not going to cover them in this lesson just because we are going through a lot and I want to make sure that I'm mindful of your guys' time. If we turn to the next 2 pages, 197 and 198, those are also practice pages that we will be covering on Tuesday. So keep flipping until you get to page 200. So now for page 200, we're going to be talking about Joelle, and she's buying boxes of bananas. So Joelle bought 2 boxes of bananas for her ice cream shop, because of course. And there are 8 bunches in each box. So each box has 8. There we go. All right. So now here again is that opportunity to use the distributive property. So she says, are there, 8 bunches in each box, and there are 5 bananas in each bunch. Ah! let's try this again. 2 boxes. Each box has 2 bunches. Has 8 bunches. Darn it! This is not going to work out for my picture. 2 boxes. Each box, 8 bunches. Each bunch, 5 bananas. You can see why it's important to have simple math drawings, because even your simple math drawings can get confusing. All right, so here's one box with 8 bunches in the box and 5 bananas in each bunch. I'm going to need to do the same thing for the next box, because each box has 8 bunches and 5 bananas in each bunch. Okay, so for our model it, you can think of a multiplication problem that you can write, or you can also use diagrams to help you understand the problem. So I've tried drawing a picture. That can work because now I have all of my bunches. I have all of my 8 bunches for 2 boxes and my 5 bananas in each. So I could go around and say I have 5, 10, 15, 20, 25, 30, 35, 40 here, and 5, 10, 15, 20, 25, 30, 35, 40 here. So that would be like 40 and 40 to make a total of 80 bananas. But let's go ahead and look at how the book is telling us. So for the first model it, they're saying we have 2 boxes times 8 bunches in each box times 5 bananas in each bunch. We can go ahead and change the order of the numbers, and we can group them differently as well. So I could flip these around and say now I'm going to have 8 times 2 times 5, and then I'm going to group these. Now I have 8 times 10. 8 times 10 would make 80. Now I know I did that fast, so I'm going to slow it down. First I'm changing my order. Now I have a problem that reads 8 times 2 times 5, right? So I've just taken my order and I've flip-flopped it because I didn't like it in the first order. Now I'm going to take my grouping and I'm going to group the 2 and the 5 together because I know 2 and 5 makes 10, and I know 10 is super easy to multiply. So now I have 8 times 10, and my answer is going to be 80. The second model it is showing you with a diagram. You still have 2 times 8 times 5. But it's showing you with your diagram that you can combine them however you like. If I multiply 2 times 8, that would get me 16. And then I can multiply it by 5. But let's say I don't really feel comfortable doing that. I could also say I have 5 times 8. I know that's 40. Then I'm going to have 2 times 40 is going to make 80. I can also do it as changing my order. 2 times 5 is 10. 10 times 8 is 80. So I'm still getting the same answer no matter how I group my numbers or how I switch the order. All right. Gosh, my pages are super sticky today. All right, so because this is the same principle that we are applying, but I am going to go ahead and cover a couple problems on page 201. So turn to the next page, 201. Number 1 says you can order and group the factors in the multiplication expression 2 times 8 times 5 in different ways. Look at the ways shown below and fill in the missing numbers. So the first one they show, so we have 2 times 8 times 5 is our original problem. The first one shows 8 times 2 times blank equals 80. So for this, I'm going to look at what is the number that is missing. I have 2 right there. I have 8 right there. So I know that my missing number has got to be 5. So I would fill in 5 on the blank because I still need to have all 3 numbers to get to my answer of 80. Okay, let's go ahead and look at the next one. The next one says I have 5 times 2 grouped together times something to still equal 80. Well, I've got my 5, I've got my 2, so the missing number has to be 8 to make my equation still true. So I've grouped it in a different way, but I'm still using the same number. Okay, oh my goodness. The last one on there says we have some number times 8 times 5 to make 80. I have 8, I have 5, so my missing number has got to be 2. So here we didn't change the order, it's the same order. We just decided to group the 8 and the 5 together by putting those parentheses. The parentheses say that we're doing that first. So we're going to find what 8 times 5 is first, that's 40. Then we're going to multiply it by 2 to get our final answer of 80. So this is just all about how you're going to break up steps so that you can multiply bigger and bigger numbers. And this is going to come in especially important next year when you guys start working with multiplying multi-digit numbers. Okay. So I changed my mind. We're actually not going to cover number 2 on page 201. And we're also going to skip page 202. Again, if you need a little extra practice, I'd highly recommend completing the problems on these 2 pages. But for the sake of this video, we're going to go ahead and keep moving. So pages 203 and 204, we will also be covering in our practice page section. And then pages 205, 206, 207, and 208 are available for extra practice if you want to do some extra practice, but again, not required. All right, I will see you guys on Tuesday for more fun in order and grouping of multiplication. One thing that we didn't really cover in this lesson was that distributive property, because we will be working with that more on its own next time. All right, see you guys later.